we are going to analyze the volume content of oil, water, and solids, in this particular case using a sample of an invert emulsion. And for that we are going to be using a retort, which is a very simple distillation device. And I'm going to proceed to set up the instrument so that we can do that determination. Here we have some steel wool, and I'm going to get me a piece so I can make a little ball to prevent whole mud from going through the system and appearing here in the collector tube. So this will go here. Somehow loose. So we are ready to fill this cup with 10 cc's of sample, but before we are going to put this product, which is called Never Cease, and that's a brand name. And the reason we do it is because this is going to be very hot. You might have some fluid to make sure that we are able to unscrew it after we finish the analysis. So this is going to act as a kind of a lubricant, high temperature lubricant. That's done. I'm going to proceed to fill up this with approximately 10 cc's. Looks pretty full. Now the cap has a hole here so that it will allow a bit of an overflow. Now I do have an overflow. So I'm going to go ahead and clean the excess to make sure that I have exactly 10 cc's inside this container. Now I can proceed to screw this so that distillation may start. So we are ready to put it in the heating element. And now, before we place the receiver, we are going to just put 2 or 3 drops of a wetting agent. The wetting agent, we are going to make sure that we rotate it and gets all the glass inside wet, so we can have a better reading, especially of the interface between oil and water. This is enough. I'm going to just make sure that I have all the rest. And now we can put this in place. Okay. We're going to put a little tape here to attach it to the bench. The reason I'm putting the tape is to prevent an accidental detachment of this tube, and so now it has a more stable, steady position. And I'm going to plug the instrument. The instrument has a thermostat which will make the temperature in that particular 10 cc cell of approximately 950 degrees Fahrenheit. So now it's going to heat, as we can tell by the light on, and eventually it will disconnect itself once the distillation process is over, and then we can just proceed to measure the collection of liquids. So there's nothing really to watch. This instrument can be left alone while the mud engineer, for example, takes care of some other analysis. So basically what we are going to do is measure the total of liquids, also itemizing, for example, water and oil. And the empty volume here is going to correspond to the solids which did not go through the system, and they are going to be burned and remain in this cup. So what we can do is determine the solids by default as a difference between 10 minus all the liquids that we get in this collection tube. We can already see that here we have water, very clear, and this is some oily substance, clearly some part of the oil phase of the invert emulsion. Also, there's good ventilation here. Just notice that the light went off. We just unplugged it for safety reasons. That doesn't mean that the experiment is finished, because we see that it's still very hot and it's still dripping. So the correct thing to do would be for us to wait until the dripping stops and then proceed to measure the fluids. The dripping has stopped, and here we can clearly see 13% of water, and then total liquid 64. 64 minus 13, that would come to 51% oil. And so if we have 64 total fluids, that means that our solids percent, total solids percent, will come to 36. 36% solids, which is a reasonable amount of solids to have for a fluid of this particular mud weight. With all those figures, we can make a lot of calculations using material balance or a computer. We already know the density of the water, the density of the oil or continuous phase, also we call it non-aqueous phase, and then we can determine the density of the solids to be able to then discriminate and itemize high gravity solids and low gravity solids, which is an information that is very useful to the mud engineer.